right, let's talk about conditional statements and all the fun things about it. Conditional statements, first things first, are given to you as if P then Q. Its variations, I'll put the converse, is if Q then P. The inverse is the opposite of P, or the negation of Q, opposite negation. And the contrapositive is going to be the negation of Q, then the negation of P. And the biconditional is P if and only if Q. Okay, so that is what we are dealing with today. We are turning these sentences, these knickknacks, into statements. And for the ones that make sense, we're going to find out if they're true or false. We'll take it from there. All right, so first things first, if hypothesis then conclusion. What we have to do is we have to determine what my hypothesis is, my P, and what my conclusion is, my Q. So hypothesis, the word hypothesis is my P. My Q is going to be my conclusion. So when I'm asked to write out the converse is when you take this information and flip it. So instead of starting out with if hypothesis, you would say if conclusion, then hypothesis. The inverse throws knots in front of these things. So not like K-N-O-T-S, like N-O-T-S. So the inverse is you normally go in the normal way that you do, but you say if not the hypothesis, then not conclusion. The contrapositive is the same as the inverse. I'm sorry, the contrapositive is a mix of the converse and the inverse. So what you're going to do is you are going to put it in the order if P then Q, but put knots in front of them. So if not conclusion, then not hypothesis. Last but not least, the biconditional has you take this and rephrase it so that you say P if and only if Q. So hypothesis if and only if IFF conclusion. And since none of these statements really make sense, we're not going to find out the truth value behind these. We're just going to leave it as that. Okay? So those are the basics. Those are the basics. Let's actually do a problem that, is real. So what did I do? Blue and red. Let's do purple and green. A shape is a square is going to be my hypothesis. And my conclusion is it is a rectangle. So, the converse is when you take it and flip it around. So, if And maybe I should have a shape as not part of it, but if a shape is a rectangle, then it is a square. We'll find out the truth values later. The inverse is when you take the original statement, the original conditional, and throw knots in front of them. If a shape is not a square, then it is not a rectangle. A contrapositive is like a converse with inverse words thrown in it. So if a shape is not a rectangle, then it is not a square. Just made it. The biconditional is when you have the hypothesis, if and only if conclusion. So a shape is a square if and only if it is a rectangle. So let's find some truth factors behind all of these. Let's see if these are true. Let's look at the conditional first. If a shape is a square, then it is a rectangle. That is true. Squares are rectangles. If a shape is a rectangle, then it is a square. Well, that's not necessarily true because a rectangle doesn't have to be a square, so we'll say false on that one. If a shape is not a square, so like a circle, then it is not a rectangle. Well, I could still have a rectangle if it's not a square. So I could say, well, a rectangle is still a square, so that's false. If a shape is not a rectangle, then it is not a square. Well, that's true. If it's not a rectangle, then it can't be a square because a square is a type of rectangle. So that's true. And a shape is a square if and only if it's a rectangle. That's true. So fun fact, the conditional and the contrapositive are always going to be the same truth value. And the inverse and the converse are also always going to be the same truth value. Trying to find different colors, but we'll go back to the America colors. If Johnny wants to be a doctor, then he must go to medical school. That's true. Actually, that's not true because you could be a doctor in education. We'll worry about that later. Wants to be a doctor is my hypotenuse, my hippopotamus. And then must go to medical school. He must go to medical school is going to be that's supposed to be a Q, but that looks more like a G, so let's just do that. That's my conclusion. The converse. If Johnny goes to medical school, then he wants to be a doctor. The inverse. If Johnny does not want to be a doctor, then he must not go to medical school. If Johnny does not go to medical school, then he doesn't want to be a doctor. Johnny wants to be a doctor if and only if he must go to medical school. All right, so let's just say that Johnny wants to be a surgeon. Okay, let's not be nitpicky here. Let's say Johnny wants to be a doctor of medicine. Okay, that's what we mean by doctor. So we're going to say that this is true. If Johnny wants to be a doctor of medicine, then he must go to medical school. Great. If Johnny goes to medical school, then he must want to be a doctor. Well, maybe, so let's just say he wants to be a brain surgeon. Johnny's going to be a brain surgeon. If Johnny wants to be a brain surgeon, then he must go to medical school. So if Johnny goes to medical school, then he must want to be a brain surgeon. Well, no. That's not necessarily true. Maybe he wants to be a doctor that treats cancer, or maybe he wants to be a heart surgeon. I don't know. If Johnny does not want to be a doctor, then he must not want to go to medical school. Well, that's not true. Maybe he doesn't want to be... That's not necessarily true. If Johnny does not go to medical school, then he must not want to be a doctor. I'll agree with that. And Johnny wants to be a doctor if and only if he must go to medical school. Well, that's going to be true, of course. So, that, boys and girls, wraps up all that beautiful paper and pen for conditional statements and the like. Bye.